Okay, in this video, we're going to talk about section 1.4 dealing with trigonometric functions and their inverses. And I do need to mention that there will be 4 parts to section 1.4. Okay, so this section will be broken up into 4 different videos here. In this first video for section 1.4, we're going to talk about radian measure, and we're going to be converting from radian to degrees and also from degrees to radians. And that'll be it for this section. Okay, everything else will be talked about in future videos. All right, now let's talk about a radian measure here. In calculus, it typically requires that angles be measured in what they call radians or RAD. Okay, so here when we're working with the circle of radius r, the radian measure of an angle, which we're going to use as the Greek letter theta. Okay, and I will write that Greek letter up here. Theta is the Greek letter. Okay. So radian measure of angle theta, that's going to be the length of the arc that's associated with theta. Okay. So in this, you're going to see here's a coordinate plane with the angle theta that you see here. That angle is going to be associated with this arc, which is a piece of a circle, by the way. And it's denoted by S, okay? And that's just the length of that arc, or a piece of that arc, divided by the radius of the circle. Okay, so if we work with the unit circle, the radian measure of an angle is just simply the length of the arc associated with S, with theta. And by the way, the unit circle is nothing but a circle that has a radius of 1. Okay, and the circle is at the center of the coordinate plane. And of course, from the center of this circle to a point on that circle is the radius, and the radius is going to be 1, which is why we call it the unit circle. Okay. And also, the length of the full circle, that's all the way around, is 2 pi. Okay. Okay, because you go from 0 all the way to pi, and then again, another pi. That's 2 pi. Okay, so now since the circle is 2 pi, that's from beginning to end, then half of a circle would be pi. From here to here, that's half a circle. That's pi. And in this case, pi would be 180. All right, so if we have an angle with the radian measure of pi over 2, then that's going to correspond to the quarter circle, which is this. From here to here, that would be a measure of 90 degrees. Okay. Now let's talk about how to convert from radians to degrees, and then from degrees to radians. And here's the conversion that we can use here. If I want to convert from radians to degrees, okay, and radians is going to be something in terms of pi, then that means we need to multiply it by 180 over pi radians. Okay. And then to convert from from radians to degrees, you're going to multiply pi radians over 180. So that's what you'll use here. And notice that both of these are just reciprocals of each other. So from radians to degrees, we use this conversion analysis, 180 over pi radians. And then from degrees to radians, we do pi radians over 180. All right, now on the next page is just some examples of just this. So the first thing we do here is, in example 1, convert from degree measure to radian measure, from degree measure to radian measure. So in part A, we got negative 216 degrees. Negative 216 degrees. And I want to convert that to radian measure. Okay. Let me use a different pen. So for 216 degrees, and negative 216 degrees, I should say, here we're going to multiply it by that conversion factor or conversion expression. From degrees to radians, we use pi radians over 180 degrees. So this will be pi radians divided by 180 degrees. And when we do that, the degree symbol divides out. So your answer will be left in terms of pi. I'm going to treat that 216, negative 216, as negative 216 over 1. So this would be negative 216 pi over 180. Now, of course, we want to put this in simplest form. So using our calculator, if I do, let's say negative 216 divided by 180, and then press math, and then select menu item number 1 for fraction, it will be negative 6/5 in simplest form. So with the pi, it will be negative 6 pi fifths. Negative 6 pi fifths, or negative 6/5 pi, if you want to write it that way. Okay. So that's how we convert from degree to radian measure. Part B, 450 degrees. Let's convert that to radians. So here, using that same conversion, it'll be pi radians on top, and we're converting from degrees, so the degrees have to be in the denominator. So it'll be 180 degrees in the denominator. That way, your degrees divide out, and 450 will be 450 over 1. So 450 times pi will be 450 pi divided by 1 times 180 will be 180. So it'll be 450 pi divided by 180. I'm going to do 450 divided by 180, then press math, and then select number 1 for fraction. Now it would be 5/2. And I can write this as 5 pi over 2, or just 5/2 pi. Now I'm thinking in the homework, in my math lab, they're going to want it like this: 5 pi on top and then the 2 in the denominator. All right, part C, negative 150 degrees. I want to convert that to radians. So negative 150 times, we're going to use that same conversion, pi radians over 180 degrees. Then that's equal to, in this case here, let me put that degree symbol there. You're going to see those degrees divide out. So now negative 150 will be negative 150 over 1. So that will be negative 150 pi over 180. And then I'm going to try to use my calculator to reduce negative 150 over 180 in simplest form. And this will be negative 5 pi over 6. Or we can write it as negative 5/6 pi. Okay, so that is how we convert from degree measure to radian measure. All right, example 2 is to convert from radian measure to degree measure. Starting with part A, we got 3 pi over 20. Now I'm going to convert that. And by the way, this is in radians. And I'm going to convert that to degree measure. Okay? Because radians has pi in it, as you can see in each of these. Now we want to convert to degrees. That means we're going to be using, in this case, this conversion from radians to degrees. We multiply 180 degrees over pi radians. So here, that will be the conversion that we'll use. 180 degrees on top. The radians have to be on the bottom, so it'll be pi radians. Okay, so you can see 180 degrees will be on top. Pi radians have to be on in the denominator. So radians divide out. Not only does the radians divide out, so does the pi. That has to divide out always when you're converting from radians to degree measure. Okay, so here we got 3 times 180 divided by 20. So this is 540 over 20. And if I do 540 divided by 20, it will be 27. This will be 27 degrees. So 3 pi over 20 in degrees will be 27 degrees. All right, part B, 11 pi over 6. 11 pi over 6. And again, this is in radians, so I'm going to write the 11 pi over 6, and that is in radians. So now we need to convert that to degrees using the same conversion. So it'd be 180 on top with the pi radians in the denominator. And again, the pi in the numerator and the denominator divide out. Also, radians divides out as well. So now we have 11 times 180 divided by 6. Now go ahead and do that in the calculator as well. 11 times 180 divided by 6, which will be 330 degrees. So 11 pi over 6 radians converts to 330 degrees. And finally, -9/4. So here, this is a negative 9 pi over 4. And that's in radians, by the way. Now we're going to multiply it by the same conversion analysis. That's 180 degrees divided by pi radians. So here the pi divides out, radians divides out. So here we're going to be left with -9 times 180 divided by 4. And this is in degrees, by the way. So here, -9 times 180 divided by 4. So this will be -405 degrees. Okay, so that's how we convert from radians to degree measure. Okay, so that will conclude part 1 of this video on just a radian measure and how to convert from degrees to radians and from radians to degrees. Please feel free to email me if you have any questions about the homework for part 1 of section 1.4 or anything that's been presented in this video.